Hey everybody, John here. We're going to talk about exponential functions today. And basically what an exponential function is one where the variable is the exponent. So up until now we've had exponents raised to some power. Those were our polynomials. And then sometimes we had a variable raised to an exponent over some other variable raised to an exponent. And those were our rational functions. But now we're going to talk about exponential functions where the variable is the exponent. So this is an exponential function with base a. So the base is a in this case. It's the thing that's being raised to the exponent. And all exponential functions have a domain of all real numbers. So let's go through and evaluate some of these exponential functions, and we're going to be using our exponent rules, which we'll go over on the next slide. But these are exponent rules that you should already know about, and we're going to try to do as many of these as we can without a calculator to sort of review those rules. So our first function, f of x, is 3 to the x minus 2, and we want to find f of 4. So I'm going to plug 4 in for x. So we have 3 to the 4 minus 2, and 4 minus 2 is 2. We do what's in the exponent first because the exponent acts as a grouping symbol. So we have to do the 4 minus 2 first. So now we have 3 squared, which is 9. So f of 4 equals 9. Which would be like the ordered pair 4, 9. This point is on the graph of this function. So now moving to g, we know g of x is negative 2 times 10 to the x. And because of our order of operations, we have to deal with exponents first. So 10 to the x has to happen first. Then we multiply by negative 2. You are not, under any circumstance, allowed to multiply negative 2 and 10 and still keep it raised to the x. This is wrong. Okay, this is not correct. I'm going to erase it. So first we're going to raise 10 to the negative 2 power. I'm plugging negative 2 in where x was, because this is telling me to evaluate this at negative 2. Now, a negative exponent means that the base is in the wrong place. So right now the base is in the numerator, and so we want to take the reciprocal of that and put it in the denominator. So this is the same thing as negative 2 times 1 over 10 squared. And once the base is moved to the correct location, the negative exponent becomes positive. 10 squared is 100, and so this is really negative 2 over 100. That's my final answer here. So g of negative 2 is negative 2 over 100. So h of x is 1/9 raised to the x power. And if we're looking for h to the negative 3/2, this is a rational exponent. This is just a fraction, negative 3/2. But when I plug it in to my equation, it's the exponent. And so this is a rational exponent. And so first let's deal with the negative that's out in front. That negative is telling me that the base is really should have the reciprocal taken. So the base is not correct. This is really 1 over 1/9, which 1 divided by 1 divided by 9 is just 9. So this is really 9 to the 3/2. So we got rid of the negative exponent. And again, 1 over 9 equals 9. Okay? Oh, sorry. That's not right. 1 over 9 equals 9. There we go. That makes more sense. When you're dividing by a fraction, you multiply by the reciprocal. So the reciprocal of 1/9 is 9. And that's what the negative exponent means. It means the base is either in the wrong place or you need to take the reciprocal of it, but both of those mean the same thing. So now we have this rational exponent. The denominator of the exponent is the root, so this is really saying take the square root. And I'm actually going to take advantage of one of the properties of exponents, and I'm going to think of this as 1/2 times 3. 1/2 times 3 is 3/2, and I can split up the exponent this way. Now 9 to the 1/2, this is really saying take the square root of 9. Okay, well the square root of 9 is 3. And now I have 3 cubed. 3 times 3 is 9, times 3 is 27. So my final answer, h of negative 3/2 is 27. And if you'll always have your calculator, but if you're in a position to do this without your calculator, always do the denominator first, because you want to make the number smaller first. Like 9 cubed, I could figure that out. 9 times 9 is 81 times 9. It's just not as easy as doing the square root of 9 and then 3 times 3 times 3. Okay? I think it's 729, 9 cubed, and then the square root of that is clearly 27, but I wouldn't know the square root of 729. I only know it because I know I was supposed to get 27. So make the number smaller first before you make it bigger. Now this last one, big F of x equals 4 to the x, we're supposed to find f of 3.2. Now, I can't do this without a calculator, so I'm actually just going to put this in my calculator. I'm going to do 4, I'm going to, 3.2. I'm going to use the caret on my calculator, so I'm going to press 4, then I'm going to hit the caret, which is the button right above division, and then I'm going to type in 3.2 and hit enter, and it gives me 84.449. And I just like 3 decimal places. If you're going to use a decimal, 3 decimal places rounded or truncated. So if you had the answer 84.448, that's truncated, that would be okay as well. Now I'd pay attention to whatever Pearson says you should round to. If it says to round, and if it says to round to the nearest tenth or whatever it is, just follow the instructions there to make sure you get the right answer. Okay, so to evaluate these, not only did I need to know about function notation, which is review of previous material, but I also need to know these rules of exponents. Okay, when we multiply like bases, we add the exponents. When we divide like bases, we subtract the exponents. When we multiply two bases together and raise them to an exponent, it's like you're raising each number to that exponent. When you raise a power to a power, you multiply the exponents. Anything to the 0 power is 1, and when you are raising something to a negative exponent, it's really saying take the reciprocal. Okay? So a is really a over 1 to the negative x, and so we take the reciprocal, which gives me 1 over a to the x, but then using a variation of this rule over here, this is 1 to the x over a to the x, and 1 to the x is still 1, so that's how we get this part here. Okay. So you should already be familiar with these exponent rules. I hope you are. And I'll see you in the next video while we go through graphing various exponential functions. And we'll talk about growth and decay and sort of the basic shape of what all these functions look like.